So in our previous example, we have seen that the envelope of the amplitude modulated signal was positive for every t, but it might be possible that the envelope may be negative for few values of time instants. So now let us check what happens. I mean, what would be the structure of the amplitude modulated waveform if our ACT is negative for some values of t. If you remember that the instantaneous amplitude or the envelope of our amplitude modulated waveform was AC plus KA-mt. So let us take an example where for few values of t we can make this envelope negative, and let's see what happens to the amplitude modulated waveform for that scenario. So if our message signal is same, which we took for the previous example, am cos 2 pi fmt with fm half and the amplitude as 1, and the frequency of the message signal is 0.5 Hz. But now we increase the sensitivity, amplitude sensitivity to 2, and we take the same carrier amplitude as 1 and carrier frequency as 50 Hz as we took for our previous example. So now let us see for this scenario how our amplitude modulated waveform will look like. See, so this was our objective, and let's first plot the ACT for these parameters and let us check the whether ACT is negative for few values of t or not. So ACT is AC plus KA-mt, which will be 1 plus 2 mt, and our mt is a cosine signal with amplitude 1 and frequency 0.5 Hz. So let us put these values, and so ACT would become 1 plus 2 cos pi t. So this is our ACT. As I told you, we can plot ACT by following these 3 steps. First we plot mt. Mt is cos pi t, which we have already plotted in the last example. So we took the same mt here. Then what we do, we just multiply this message signal with factor of 2, or we are scaling our message signal. In other words, you can say that we are scaling our message signal by 2, the y-axis, right? So we are amplifying our signal. So now the amplified version of our signal 2mt would be this. It is quite simple. We have to just extend the y-axis accordingly, and then we have to add it by a factor of 1, or we have to shift it in the upward direction, correct? So our ACT or 1 plus 2 mt would be this. So you can see between 1 by 2 and 3 by 2 our ACT is negative, correct? So this is our ACT, and in order to plot our modulated waveform, amplitude modulated waveform, what we do, we first plot ACT and we also plot minus ACT. Minus ACT is nothing but the mirror image of your ACT with respect to your x-axis. So we are just taking the mirror image of your ACT, which will be this. And as you can see that now if you see our amplitude modulated signal will be this. If we start, this is our ACT, this is minus ACT, and the carrier will be following this envelope, right? So I mean, there are 2 important points to notice here. Firstly, this point is giving you phase reversal. when ACT is negative, what happens as, because this is your, as you can see, this is your ACT, right? It goes up to this point, and after this point it becomes negative. So here there will be a phase reversal, and you know that phase reversal will always give you the some problem, right? Which we will study in detail later. But you should know that on the at these points we will get the phase reversal, because here your signal ACT is, firstly it is 0 and then it will become negative, right? So the phase will become negative. So it is called phase reversal. And now if one asks you to follow the envelope of your amplitude modulated waveform, if we start following the envelope will become this, which is not the true envelope. The true message, which is not the true message signal, right? Our true message signal is this, but because our ACT is negative in this case, we are actually having a distorted envelope. So ACT, if ACT is negative, it gives rise to two problems. First is distorted envelope, and the second is phase reversal. And this is also called overmodulation, right? That we are modulating. I mean, it was not necessarily required to modulate our signal so much, right? We could have set our value of AC or some other parameters that our ACT was positive, but we have overmodulated our signal. So this is called overmodulation, and this is giving rise to two non desirable phenomenon, that is, first is distorted envelope and second is the phase reversal. So what is the condition? If someone asks you what is the condition for no distorted envelope, you say that the envelope must be positive for every t, right? For all the time it must be positive, correct? So this is true if ACT is nothing but AC plus KAMT, so it must be positive or non-negative, because it can be equal to 0, so I must say it must be non-negative. So condition for no distorted envelope is that your ACT must be non-negative. So if you write it ACT as greater than equal to 0 and you replace ACT with AC plus KAMT and you take AC outside, your equivalent condition is that this quantity should be always greater than equal to 0, and this is true when your Ka by AC and you take minimum value of MT and take its modulus, this is less than equal to 1. It is quite obvious, right? Because if MT is positive, always positive, then there is no problem, right? Because this quantity will always be positive. So first we take minimum of MT. For example, of minimum of MT is negative for some values and it is less than equal to 1, right? We'll take a few example and we'll see. So this is the condition, equivalent condition, that our ACT is non-negative, and it is true when K by AC and modulus of min of MT is always less than equal to 1, and this quantity at the right hand side is also known as modulation index, which we represent by mu. So if our modulation index is always less than equal to 1, there will be no distorted envelope. Okay, so let's take an example. We take a message signal MT whose maximum value is +2 and minimum value of is -3. Okay, we take AC as 1 and at the sensitivity for first scenario we take it as 0.2 and for the other scenario we take it as 2. So let's check for the first scenario, K by AC is 0.2 divided by AC multiplied by min of MT, its modulus, which is 3. So 0.6. So for this case, there will be, because since mu is less than equal to 1, we will not observe the distorted envelope, right? But for the second case, when your mu is K by AC, it means for the second case K is 2, AC is 1, and our mean of MT, absolute value of mean of MT is 3. So because now the value of modulation index is greater than 1, so we will see the distorted envelope. So, I mean, this is the definition which we have just studied. This modulation index is K by AC, mean of MT, absolute value, and if I have just written MP as this quantity. So, and if mu is greater than 1, we call it overmodulation, and it gives rise to the envelope distortion. There is one other name for this mu. We also call it depth of modulation. Okay, so thank you.